In this video, we are going to solve the problem how many ordered pairs of integers x, y satisfy this equation. We are given the equation x to the power of 2020 plus y squared equals to 2y. We can write this equation as x to the power of 2020 plus y squared minus 2y equals to 0. Y minus 1 whole square equals to y square minus 2y plus 1. Hence, in order to make this a perfect square, we have to add 1 to both sides of this equation. Now we can replace y square minus 2y plus 1 by y minus 1 whole square. Now the equation becomes x to the power of 2020 plus y minus 1 whole square equals to 1. Since both 2020 and 2 are even numbers, both these terms are positive. Hence, both of these terms are less than or equal to 1. X to the power of 2020 is less than or equal to 1. Also, y minus 1 whole square is less than equals to 1. For x to the power of 2020 is less than or equal to 1 and x belongs to I, we only have to consider the integer values of x. For x to the power of 2020 equals to 1, the possible values of x are x equals to 1 or minus 1, because 2020 is an even number. Hence, for x to the power of 2020 equals to 1, x can be either plus 1 or minus 1. Also, x cannot be greater than 1, because for x greater than 1, x to the power of 2020 will also be greater than 1. Now we will consider x to the power of 2020 is less than 1. This is possible only when x equals to 0, because if we consider x less than minus 1, then we have x to the power of 2020 will be greater than 1, because x is even. Let's take an example. For x equals to minus 2 to the power of 2020, which is equals to 2 to the power of 2020, which is greater than 1. Hence, the only possible solutions for x are x equals to plus 1, minus 1 and 0. Now, for the first case, x equals to plus 1, we have 1 to the power of 2020 plus y minus 1 whole square equals to 1, which gives 1 plus y minus 1 whole square equals to 1, which you can write as y minus 1 whole square equals to 0. This gives y equals to 1. Hence, one of the integer values of x and y is equals to 1, 1. Now, let's move to the second case where we will consider x equals to 0. For x equals to 0, we have 0 to the power of 2020 plus y minus 1 whole square equals to 1. This gives y minus 1 equals to plus or minus square root of 1, which is equals to plus or minus 1. So for plus 1, we have y minus 1 equals to 1, which gives y equals to 2. For minus 1, we have y minus 1 equals to minus 1, which gives y equals to 0. Hence, for x equals to 0, we have two different values. For x equals to 0, we have y equals to 2 and 0. Hence, the possible integer values of x and y are 0, 0 and 0 plus 2. Now let's move to the third case, which is x equals to minus 1. When x equals to minus 1, we have minus 1 to the power of 2020 plus y minus 1 whole square equals to 1, which gives 1 plus y minus 1 whole square equals to 1, which gives y equals to 1. Hence, the possible integer value of xy equals to -1, 1. Hence, we have a total of 4 different solutions from the above 3 cases, which are 1, 1, 0, 2, 0, 0 and -1, 1. Hence, the total integer pairs of xy that satisfy this equation are 4. 4 is our answer.